Okay, welcome to part 3 of video game design. And to start off, please go ahead and change back your code so that your rectangles are 32 by 32 pixels. And also be sure that the g.fill rectangle happens before the draw outline of the rectangle. And change the color back to burlywood. It was red before, and you might have modified it a little bit further. Now the next thing we want to do is we want to display our frames per second on the screen. And in the past, we've used labels. We've gone to the toolbox, we've grabbed a label, and we drop it on the screen. But let's, instead of doing that, since we have a bitmap here, let's use graphics to draw it out on our screen. So it's going to go something like this. G to represent our graphics, draw string, and then we're going to have two counters, one for frames, and int frame rate, and one for the frames per second, or I'll just call it FPS. And I think we called that int max frames per second. Okay. So now that we have that set up, we need to specify the font, or that we're using a font, so me.font, comma. We need to specify the color, so brushes.black, but you can change the color if you want. And then we need to specify a location where this is going to display. So let's do 650 pixels horizontally by 0 pixels at the top. Okay, and now let's just give this a run. And if you take a look at your code right now, it is displaying the frames per second, but it's really blurry up here. So let's split it down to 2 lines, and that might actually help a bit. So to get it so the frames and frame per seconds are on 2 different lines, in between them, put in the following code, VBCRLF. Whoops. Let me stop debugging. VBCRLF. And this should give a space between it. Let's run it. And as you can see, it's still running, but it's creating like a blur effect. So it's very hard to see the frames per second. And the reason it's doing this is because instead of like clearing each frame, it's just overlapping them over and over again. So it's not clearing out the screen, and it's creating like a blurred effect over here. So we can fix that. I'm going to put some lines of code down to take care of that problem. So we'll call this fix the blur effect on the screen. So first of all, let's say our graphics G is equal to graphics dot from image, and then our bitmaps BB from image. Whoops, I put an IT there. So this will help display the graphics properly on the image or on the screen. And then let's activate our back buffer graphics to keep the screen frame rate good. So create graphics. So it's also in charge of creating graphics just like G is. And then bbg dot draw image bb comma 0 comma 0 comma me dot width comma me dot height. So what this is doing is doing the same thing as the graphics are doing. We're initializing bbg as me.create graphics on this screen, and then we are saying that it can draw graphics or draw images on the screen up to the length of the screen, which is 750 by 550. And finally, let's clear out the screen. So that's going to be g.clear, and we're going to clear it out, and we're going to put a new color in its place. So you can choose any color you want. Let's just choose the color, white might be a little hard to tell. Let's do the color red. Okay, so these lines, we're pretty much dedicating some memory to the back buffer so that it's creating a smooth and constant frame rate, and it's constantly clearing it out with the color red, but it's going to be very difficult to see. So let's run this right now, and if you take a look, the frames are running. That's how many frames are happening per second, and every second it resets back to 0, and then it displays the max frames per second on the screen. Right now in this screen we have 79, 77 frames per second, which is pretty good. And if I maximize this, you'll notice that the frames per second drop significantly. And that's just because it has to draw graphics on the entire screen versus a very small portion of the screen. Okay, so now that we have a basic interface, what we want to do is we want this screen to be responsive to our mouse click. So like you could click at a particular zone and something would happen. This is particularly useful if you want a character to follow your mouse, or if you just want it to be that you can click different options on the screen. But the problem right now is the program could recognize when your mouse is like in here because this is 32 by 32 pixels. But when we maximize the screen, the pixel number changes and it becomes more difficult to track what's happening in the screen, or at least more difficult to code. So to start this program, and until we're comfortable with this, what we want to do is we want to make these pixels static, meaning we're going to lock the size of the bitmap so that it cannot change with this program. Okay, let me stop debug. I'm going to change the color also to like wheat because red is a little strong for my eyes, so I'm just going to change that. So let's scroll up here. So for our bitmap, where we're drawing the graphics pretty much, I'm going to change the width, or I'm going to hard code it as 750 pixels, and I'm going to change the height to 550 pixels. And I'm going to do the same for my back buffer graphics over here. I'm going to change this to 750 pixels by 550 pixels. And now if you run the program, you'll notice that it runs and it looks exactly the same, but if you try maximizing the screen, it actually stays within the zone of the bitmap, and there are no graphics anywhere else on the screen. So when controlling the mouse, or registering where the mouse is clicking on, we always have to assume that this is our starting point. And then from this point on, we can add to that. So if this is 0, that'd be 1, that'd be 2, that'd be 3. And that's considered like mapping where the mouse is. And we also will need to have a pixel count to register exactly where the mouse is. So we're going to need a few variables to get this started. Let me stop that. Let's go back to the top of our program, and we'll just make these global variables so it runs smoother. I'll put a little bit space there. So let's call these mouse location variables. And as far as I know, we're going to need, I think, 4 dim int mouse x as an integer, dim int mouse y as an integer, oops, I see, as integer. We'll also need something for the mapping of it, dim map mouse x as an integer, and dim int map mouse y as an integer. So we have the variables we're going to need to map out the mouse click locations. The next thing we need to do is we need to create a special procedure for this mouse. So over here where it says declarations, if you click in here, or no, not there. What we probably want to do is click inside of the form or the main program. So I think that's over here. So I'm just going to click inside of here. And now, what? Yep, there we go. You're looking for Mousemove. So if you click on Mousemove, it's going to create a new procedure for you to use. So the great thing about this procedure is that it automatically tracks where your mouse is moving, aka mouse move. And all we need to make it work properly is throw in a few lines to start. So int mouse x is equal to math.floor e.x divided by 32, and int mouse y equals math.floor e.y divided by 32. And now you're probably wondering, what exactly do these lines do? This line over here is, depending on which zone you're in the program, it always runs down. For example, when the program's running, if you are very close to this edge and you're not quite into the second square yet, it's going to register the first square still. It's not going to go into the next square because that might cause problems if you're trying to control your character precisely. So it waits until you finally cross that threshold, and then it moves to the next square. So it's a rounding function that always rounds down. Now the E is another term for our form. So if you look over here, E as systems.windows.form, E right now is another term for our form. So it's just saying our form and then the X pixel count. So our X pixel count in the form is 750. So that's the X from the form E. And we're dividing it by 32 because each of those squares in the program is 32 pixels long. So every time we go past 32, we want it to register as a new square and change the value of int mouse x into the new square value. So this is controlling the x coordinate, this is controlling the y coordinate, and now I'm going to show you something really cool with that. We're going to get it to display what number is being stored in int mouse x and int mouse y. So let's scroll back up here to, I know we did it somewhere, over here, where we're writing out the frames per second and the frames. Let's add a little bit more to this. So and VBCRLF, which is the same as just hitting enter on like a Word document. It just goes down to the next line. And mouse X, let's say, and VBCRLF, and mouse Y. So if we run it, you'll notice on our form we have mouse X and mouse Y, and they're not displaying anything. So let's add in those two variables, int mouse X and int mouse Y, to their appropriate space here. So after mouse X, let's add int mouse X, and after mouse Y, let's add in int mouse Y. And I think that should do it. Let's give this a run. And I'm going to bring out the code over here. Now, take your mouse and hover over one of those squares. Let's do the first square, 0, 0. And look, when you move your mouse on the X coordinate, the X value is changing. And when you move it down, the Y value changes. So right now, your program has been programmed to register exactly where your mouse is. And that can be useful, because we know in programming that values mean something, and if you use them in the right way, you can get almost anything to happen. So right now we've mapped out a mouse coordinate system, or a pretty basic one, but definitely a good start. So now let's go ahead and design a highlight cursor so that when the program's running, based on where your mouse is located, it's going to light up the spot where it's right now tracking. And you'll see exactly what I mean in a second. So first off, go over to your graphics. And over here is where we are drawing in all our grids or our tiles. So you need to make sure that for your highlight feature, this is happening after you've drawn out your grid. Otherwise, if you draw it inside or if you write the code in here or before it, it will automatically overwrite it every single time. And so you want to make sure it's after the grid. So we'll call this the highlight feature. And we're going just to use our graphics command. So G dot, and we're going to, let's do draw rectangle first. And we're going to do the pens dot red. So we're going to draw a outline in red. And the location is going to be int mouse x times 32, which is the size of our tiles, by int mouse y times 32. And then our tile size is 32 by 32. Okay, so these are controlling the size. These are controlling the location of this pen. So give it a run. And if you did it correctly, you'll notice that when you move your mouse around the screen, it lights up the tile where it's being clicked on. And that's because when you're hovering over here, right now mouse X and mouse Y are 0, 0, even though it kind of lingers on the screen over here. So then this would be 0 times 32, which is 0. This would be 0. And it's going to draw a new, well, it's not over there. It's over here. It's going to draw a, new rectangle over there of size 32 by 32. So let me just stop that. We can, of course, change it. Let's, instead of drawing a pen's red, let's do a brush, brushes red. Brushes red. And we got to change this to fill rectangle. Okay. And if you run this, now try moving your mouse around the screen. You'll notice it creates a fill rectangle now. And that's kind of cool also. Just a great way of tracking. So now we have graphics on our screen, and we also have a way of drawing graphics in real time on our screen with the mouse. So the next thing we want to do is focus on the actual clicking of the mouse. So clicking has a lot of similarities to mouse movement, and you might also think that while I'm moving around the screen, some of you might have played the game like Battleship before, and we can actually create something very similar where you can click on points and you can get it to display messages like you dropped a bomb at this coordinate, and we can have things happen like you sunk the battleship if you hit like certain coordinates in a certain zone. So to first start that, we used over here the Mousemove procedure. Now we want to use the mouse click procedure. So go to your main program, click inside of it anywhere, and then look for the, is this not the right one? Right here it is. And look for, the mouse click procedure, which is right here, mouse click. Click on that. It'll create a mouse click procedure for you. And now let's have it, let's have a message box display. So you should be fairly familiar with message boxes. And it will tell you what tile you're attacking. So you attacked tile and then we will do int map mouse x, or int mouse x. And that's supposed to be an and. You attacked int mouse x and we'll just put a space. And int mouse y. Close that off. Okay. So when we click on a tile, mouse click, that's what this procedure does. A message box will display telling us that we attacked the current int mouse x value and the current int mouse y value. So give it a run, get your program out, and then click on a spot. And if you did it correctly, it will pop up with a message saying you attacked tile 16.3. If we look at our x and y coordinates right now, it is at 16 and 3. So hit OK, click a different tile, and you attacked a different tile. So we already have some feedback here with our program. This is pretty nifty. We can definitely do cool stuff with this. But we are at about the 20-minute mark, so that's going to conclude part 3. We're going to continue this part 4 and move on with the rest of the video, or with the rest of the game. Okay, till then, see ya.